Okay, we're in chapter 2, dealing with 2.7. We're dealing with solving inequalities. We're going to determine whether a given number is the solution to an inequality. We're going to graph an inequality on a number line. We're going to solve inequalities using both the addition principle and the multiplication principle. And then we're going to use them, combine the addition and the multiplication principle together. It's not as hard as you think it is. Okay. An inequality is a number sentence containing the greater than, less than, greater than, equal to, or less than, equal to signs. So a replacement that makes an inequality true is called a solution. The set of all solutions is called the solution set. When we have found the set of all solutions of an inequality, we say that we have solved the inequality. So for example, we're going to determine x is less than 5 if a is negative 4. I'm not sure. And then b equals 6. So for the first one, if we say negative 4 is less than 5, is that true? So yes, so negative 4 is a solution. And then we're going to say is 6 less than 5. That is false. So 6 is not a solution. Now when you're graphing inequalities, because of solutions like inequalities x is less than 4, there are too many numbers to list. So you can do a number line or graph, and we're going to show you how that works, okay? So if we're going to graph the first solution, is x is less than 3. I'm going to go over to finding 3. Okay, I found 3. Now, the way it's done in your book and the way it's done in a couple of different books, it just depends. Because there's no equal to bar, you're simply just going to create a parenthesis like this. And you notice the x is on the left-hand side. If I go in and I create an arrow like this, with the inequality, it tells you which way to shade. So it's actually this way. So it goes to infinity. Okay, it goes to infinity. It didn't say it equals 3, so we don't include 3. It's any number that is less than 3 that goes on. And we're going to talk about the fault in our stars. If you've taken English 101 or English 102 this semester and you've been doing the Common Read, or you've seen anything about the Common Read, we're going to tie that into about infinities later. So I want you to be aware of that too. The next slide is going to say y is greater than or equal to negative 4. Y is greater than or equal to negative 4. And because it has that bar, we're going to start with negative 4. Now think about it. If I go in there and put a line right here in the B of that inequality, it tells me my arrow's got to go to the right. It's because my variable's on the left-hand side. It tells me my variable's got to go to the right. So I'm going to draw a bracket here, and I'm going to shade all the way to the right, and I'm going to draw an arrow because it keeps going. Okay? Now, number 5 has C has a couple of different things. It has negative 3 is less than x, and then it also has x is less than or equal to 5. So I'm going to break this up into two equations. First one I'm going to break it up is, and I'm going to change it because we practiced some of this, remember? X is greater than negative 3, and then I'm going to leave this one as it is. X is less than or equal to positive 5. So if we draw our arrow right here, and there's no equal to bar, that means we're going to have this shaded this way. Don't draw it all the way out yet, because we have two things going on. And then the other one is we're going to go this way. So I'm going to start at 5, and it has a bracket because it has the equal to bar. So it's everything in the middle, in between here, that makes that statement true. So if A is less than or if A is less than B and you add C to both sides, it would still be the same statement. Okay? If A is less than or equal to B and you add C to both sides, it's still going to be the same statement. It's not going to change anything. If A is greater than B and you add B to both sides, A plus C is still greater than B plus C. And then if you have A is greater than or equal to B, then if you add C to both sides, it's still greater than or equal to. Those are not going to. So for example here, if you just think about this as if it's like an equal sign in there, we're going to go in and subtract 6 from both sides. So now I have x is greater than or equal to negative 4. I mean, not equal to, it's just greater than negative 4. So I'm going to go in here and I'm going to graph it this way, and the arrow is going to go that way, and you are done. Alright, so we have 4x minus 1 is less than or equal to 3x minus 4. I'm going to get my variables all on one side. So I'm going to subtract 3x from both sides. So now I have x minus 1 is less than or equal to, this time, negative 4. I'm going to add 1 to both sides. So now I have x is less than or equal to negative 3. So I'm going to draw a bracket, and it goes in this direction. It goes in that direction. The same thing when you're talking about the multiplication principle. So anytime you have A or B to it, and you multiply both sides by C, the signs are not going to change. Okay, the signs are not going to change when it's positive. But now when you multiply or divide by a negative, that inequality sign changes directions. Okay, it changes directions. So we're going to talk about that. Let's practice some of those. So if I have 7x is less than or equal to 35, if I divide both sides by 7, what do you notice about that 7? It's positive, right? So x is less than or equal to 5. So we draw the bracket and we shade this direction. Okay. When you're dealing with this next one, you have negative 4y is less than 20. I'm going to divide both sides by negative 4. When I do, y now becomes greater than negative 5. When you divide by a negative, you flip that inequality sign. It changes directions. Divide or multiply. By a negative number, the sign, the inequality sign, changes direction. And that's messy. I wish you could see how I have to write on this sometimes. But y is greater than negative 5. So I'm going to put my greater than symbol, and I'm going to shade everything to the right. It's greater than negative 5. This problem is x minus 3 is less than x plus 7. So we're just going to solve it like you normally would. I'm going to add 3 to both sides. Oh wait, I don't normally do that. I move my variable first. So I'm going to subtract x from both sides. So I get 2x minus 3 is greater than 7. I'm going to add 3 to both sides. So now I get 2x is greater than 10. So I'm going to scoot over here to give us some room. Divide both sides by 5. I'm sorry, by 2. Gosh, I'm already giving you the answers. Divide both sides by 2. So x is greater than, not equals, is greater than 5. And there's no equal to bar, so it's just like a parentheses, and it shades to the right. Now this one we got to do some distributing and making sure we get everything like we need to. So let's start here. You got to clean up everything. So I wind up with 5x minus 15 minus 7x is greater than or equal to 4x minus 12 plus 9. We gather like terms, so I wind up with negative 2x minus 15 is greater than or equal to 4x minus 3. I'm going to subtract 4x from both sides. So now I wind up with negative 6x minus 15 is greater than or equal to negative 3. I'm going to add 15 to both sides. We're going to go over here and work. So I wind up with negative 6x is greater than or equal to positive 12. I'm going to divide both sides by negative 6. Don't forget what happens to that inequality sign. It changes directions. So 12 divided by negative 6 is negative 2. And we have that equal to bar, so x is less than or equal to negative 2. So we'll put that bracket in there and we shade to the left. Last example, and it's dealing with decimals. Just punch it in your calculator. You have 15.4 minus 3.2x is less than negative 6.76. This one didn't say graph, it just says to solve. So all we're going to do is solve. So what I'm going to do is I'm going to subtract 15.4 from both sides. So I'm left with negative 3.2x is less than. So I'm going to take my calculator and I'm going to punch that in. So I get 16.76 and 15.4. So I get 22, negative 22.16 divided by, oops, not the x, divided by the 3.2, the negative 3.2. So now I get x is less than or equal to 6.925. And that's your final answer. We will work some of these in class.